Our next speaker is, he will be actually be live streaming in. He's Dr. Simerject Virk. He is an ag engineer with University of Georgia, and we're trying to get him to come up.
All right, thanks, Janice.
I hear him.
Can you hear me well and see my screen?
Yes, we're good.
All right, I'll go ahead and get started.
Let's make sure we got our other computers.
All right, Mr. Ariel, that good?
He's good. You're good. Go ahead.
All right, thanks, Dennis. And again, I appreciate the opportunity today to share some information on the planting or planter setup or operations. I have given a lot of planter talks, never had this title before, and appreciate Dennis giving me a little different title to talk around. And but I'm gonna do my best to kind of give you a little bit more insight on some of the work we've been doing. Gonna jump straight into, we talk a lot about planter setup and importance in corn, because there's a lot of research in the past that suggests, or even today, that we need that timely and uniform stand establishment to maximize yield potential in corn. And a lot of times, more often than we see, the poor or uneven stands we see in the field are related to either planter issues or some of the planting mistakes we may have missed because of some of the planter setup or not paying attention to some of the settings. So I'm going to focus today on is just few considerations for some critical planter components, some planting technology, because we've been hearing a lot about new technology every day, especially for planting, and even going a little far as how you can, for those who are already using the technology, how you can use some of that data or even approach variable seeding, just take it a step further. So I know we talk a lot about that stand establishment, but what's behind that stand establishment on a planter is we always want to make sure that we have the right seeding rate. And then another thing we talk a lot about in corn is the seed placement, which is having that right seed spacing, seeding depth, and that seed to soil contact. I know there's a lot of other setups, common setup things, on a planter, but what I'm going to focus today on is these three things that affects, or these systems on a planter that affects that seeding rate and the seed placement. It's the seed delivery system, or the meter, our furrow opening system, and then the furrow closing system, which provides us that optimum seed to soil contact. I'm going to jump straight into, I know you guys heard a lot about, meter setup or inspecting your meters earlier in the season to make sure that we don't have any parts or components that are not damaged. Look for all the seals, brushes, and everything, and make sure, like even on the new seed meters that you can see in the bottom here, make sure that our correct crop kits are installed, because every crop has a different kit these days for these new meters. Something I'm going to emphasize here is seed singulation, because that's what determines your meter's performance. And what seed singulation is, most of you all probably know, but again, we'll kind of reiterate that it's how well is your meter performing. A meter with 100% singulation means we're getting no skips and no multiple. That's what we want. And then anytime we get any skips or any multiples, we're losing that singulation. We're degrading that meter performance. And what affects that singulation? Almost about anything on that planter. Meter setup is the first one. Your vacuum, your ground speed, row unit vibrations when you're planting, your field conditions. I got a couple of graphs here showing, because we did some tests with different type of seed meter plates. And if you look closely, like this is for a standard John Deere plate, anytime you're outside that 8 to 10 PSI range, you see your singulation dropping and the number of multiples increasing. And that's why make sure you look at the optimal vacuum range for each plate. Similarly here for the ground speed, because it's going to make that, as we increase speed, it's going to make that meter spin at a lot higher speeds than what it's usually recommended. So anytime we go over 4 or 5, now unless you have the high speed planting equipped planter, anytime we go over 4 or 5, you're going to see this reduction in the singulation, which is directly affecting your population and stand establishment. So again, this picture speaks a lot more than what I'm trying to say here. You know, when you have a good singulation and uniform seed spacing, your stand's going to look more like this, right? And then anytime we have a poor singulation and uneven seed spacing, you'll see a lot more issues like this in the field. So how do we check seed singulation? Well, there are two different ways I would recommend, because there may still be a lot of growers who may not have any seed monitor on their planters. So for those, this is even critical that you make sure that you're checking your seed meters before the planting season on a test stand. And it's offered both by Precision Planting and John Deere and different dealers. So what it tells you, you take the seed meter there and they test it out for singulation, and it kind of tells you how well is your seed meter performing, how many skips and multiples at that settings, and they kind of diagnose what issues or what all components may need to be replaced or repaired. Again, I'm going to say, I emphasize this if you are not using any seed monitor in your planter. Now, if you do have a seed monitor where you can look at the singulation real time while planting, make sure you're keeping an eye on that singulation, especially right before planting. You can do a static test run. Most planters offer these options, or in the first few passes in the field. Make sure you're keeping a very close eye on all the row units and fix those row units before you plant your whole field or any other fields. Then again, I'm going to do this technology pitch here. You know, this is probably one of the most common basic technology in planting. If you don't have it, you definitely need to consider it. Why? Because you want that real-time planting information, seed singulation, make sure your population is not under and over, and what your seed spacing or seed quality looks like. We do have a lot of planting technologies today, but this is the one that I would highly recommend if you don't have it already. Seed spacing, what affects seed spacing? Before I talk about some of the parameters, one of the basic things to make sure is checking your seed tubes, because as our planters sit over in the off season, they get a lot of dirt or other stuff build up in the seed tubes. So make sure they're free of obstruction, they're on the row unit properly. You know, they're not deformed or bent on the edges of the seed tube. And then if you are using seed tube guards, you know, make sure that they are in the place and don't need to be replaced. Seeding depth. This is again one of the most critical components, because we need to get that depth right? For getting uniform cone emergence. When we see a lot of seed depth variations in the field, you're going to see delayed emergence or uneven emergence. What I'm going to emphasize, a lot of you are already probably doing this, where you go behind the planter to check your seeding depth. Of all of the studies we have done in the past, the more we see is that every time we look at a planter, it's a 12 row, 16, 24, you see this T-bar handle or any other planter you have, how you set your seed depth, that handle is set exactly at the same setting for all the planter row units. And also what that handle determines is how much of this opening disc is exposed, and that's what our planted depth is, right? And then we go back and measure that depth. What I was getting at earlier is the more and more data we see, and this is just one of our test planters on the station here, is that there's a lot of variability just among the row units, because the opening discs don't wear uniformly. So what I'm getting at it, when you're checking seeding depth, don't just check 1 or 2 rows or 4 rows, you know, check every row, planter row behind the planter. It's going to have a big impact, you know, on your planter performance. Check every row. And it is very common, because I have heard, like, I set all my handle or depth setting to all the same on the planter. It is very common that to achieve the right depth, your depth setting on different row units can be different. It could be, it's not going to be very, like, at least 2 or 3 holes different, but it's very common that it can be at least 1 or 2 holes different. And then adjust that depth and downforce to minimize any variations you may see. The reason I mentioned downforce, it's gotten a lot of emphasis in the last 4 or 5 years. We have even technology for some of the active downforce in corn. Research, again, we don't need too less or too much. It has to be optimal. And I got two different thoughts on that from a lot of research we have done. Anytime you have uniform field conditions, what do I mean by uniform? Where there's not a soil variability, moisture, or any other things that may affect your planting. If you have a very uniform field conditions, you may be able to use that one downforce that will work best to attain that seeding depth. Just showing some examples here in this graph, we kind of tracked emergence for 3 different downforces. And as you can see that for that higher downforce, we didn't get another 5%. There was about 5% reduction even in the overall emergence. And this is a different study here showing the yield. We have seen some differences, from downforce on corn specifically, not as much in cotton or peanuts, but for corn where it does make a difference. So make sure that you're paying attention to that. And that's for the uniform. Now, that don't happen very often, right? We usually have, especially in Georgia where we are here, we have a lot of variable field conditions. This is kind of pictures of the same field here. If you have a varying field conditions where any of these soil conditions, texture, soil moisture, or even your tillage conditions, you have a lot different varying amounts of soil crop residue, then you're going to need that optimal downforce or a different downforce for each condition. So again, my point here in the pictures here is when we're using like 100 pounds in this sandier soil, we got a pretty good stand, but the same downforce in this heavy soil texture was just not able to get the seed planted at the right depth. We had a lot of seed depth variations and it resulted in, emergence that looked like this. And then again, here's some of the data just showing that EC3, we used the soil EC to map the texture in the field, that we had about at least 10% reduction in the stand from the sandier soil texture. Again, a little bit more on that because I'm not sure how it is in LSU over there or Louisiana, but we still have a lot of growers in our state here who does have some planters which still have these older style downforce, which is just a single spring. That does not give you a lot of option to adjust or find the optimal. So we usually recommend that please upgrade to at least options, which gives you 3 to 4 different downforce options. So you have any for usually from 0 pounds to up to 400 pounds, which gives you a little bit of flexibility to play around or adjust it based on the field conditions. Now, growers who already have this, and especially for those who are planting in highly variable conditions, we do have the active downforce technology, which is, again, on my point back in the variable conditions, that the active downforce is adjusting downforce on the go real time in the field based on your field conditions. And we have systems available from both Precision Planting and I mean to say Ag Leader here that are available out there for both, for all type of row crop planters. Some other critical row unit components before I jump on to some other technologies is, again, you hear a lot about, I know we want to talk a lot about technology and everything else, but if we miss or if we oversee some of the very basic but critical components on a planter, no matter how much technology we have on a planter, it's just not going to perform or give us the performance we need. So especially gauge wheels and double disc openers, make sure that they are set up right. There's not enough gap between, there's not a lot of gap between the gauge wheel and the double disc opener. Make sure you're making sure that it's forming a proper V and not a W. And something that we'll notice a lot of time that these disc openers not get replaced as often, especially if you're in a soil texture that wears them out very often. So anytime when your soil disc openers measure less than is more than if they're worn more than ½ inch of the original diameter, usually they are about 14.5 or 15 inches. So anything less than 14.5 inches needs to be replaced. That's also going to affect your seeding depth. Closing wheels. I know there's a lot of different type of closing options available. Some people like to use the solid, spiked, or even a single press wheel. the best thing is have them centered, and then also you may need to play around with different combinations to select the type and also the closing wheel pressure by adjusting this handle to make sure that it is suitable for your soil type and the tillage conditions that you're planting in. Row cleaners, especially for conservation systems, you're going to need them to have that clean furrow before the opening disc creates that furrow. So make sure that they're adjusted, that they're barely touching the ground. The purpose of the row cleaner is to remove the residue or trash and make sure they're not adjusted where either they're too high and not even touching the ground, or they're adjusted too low that they're almost digging into the soil while planting. I'm going to move into some of the other advanced planting technologies that are available because they're becoming more and more standard these days on the planters. Electric seed meters are replacing our standard chain-driven mechanical seed meters because they are enabling individual row control, not planting where we don't need to or turn them off in any overlap areas, turn compensation so we can maintain the same seeding rate, especially when planting in curves, and also enable variable rate seeding. If you have in trust, like I said earlier, the planters which are not equipped for high-speed planting above 4 miles, or 4.5. And if you're a grower who is interested in high-speed planting, make sure that you have the electric seed meter equipped with a speed tube. That's what provides you improved seed delivery, anytime you're thinking about planting at 8 to 10 miles. And then something else we've been seeing lately is more and more smart farmers on planters. What is a smart farmer? Basically just a seed farmer which has some sensors on the bottom which slides in the furrow before it gets closed, and it's giving us some real-time information on different soil properties, moisture, temperature, organic matter. And some of the technology we're still seeing from precision planting coming out is the real-time seed depth adjustment, but that adjustment is actually based on the feedback on moisture or organic matter from this smart farmer. So if you look at one of the advanced displays in the cab today on a planter, or if you have it, you will see this a lot more information on soil properties as we planting. And if you are one of those advanced growers who have already maximized on the planting equipment or technology you currently have, I would consider this as the next level. So as you're planting, you're looking at all this real-time soil properties. You can make adjustments on the go on the planter to make sure that you are maximizing the technology and the planter performance. Last couple slides I want to cover real quick is just because we have technology does not mean, first thing, that it does not need calibration, or it does not that everything we see on the maps is true. So what you need to do is the data we're collecting gives you a lot of power to troubleshoot or check your planter performance. So just take one of the maps from what are you looking at. Everything is being saved on your iPad, monitors, or even on the cloud. So look at the maps, find the areas. Like if we look at this Goodrite map for one of our fields, and this was way back when actually precision planting started selling everything. If you look at all this red, don't get concerned, but make sure that you're ground truthing that as applied data to make sure that when you go out in these red areas in the field, are you seeing any stand issues or spacing issues? And if you are, that your planter is performing or the sensors on there are performing as needed. You just need to make sure, how can you correct that? Is there the field conditions that needs to be, need a better planter setup, or something needs to be changed? And then also sometimes the sensor can be faulty too. So it may be misleading data. So you make sure that you're using that data to improve your planting practices and planting operation, and not just let it sit in the cab or in the iPad, after you're done planting. Last thing I want to cover, just last slide, because I know this is a planter operation talk, but if you're already doing everything else I talked about today, why not utilize that planting technology to its full potential. Make sure that you're looking into, we know that variable rate seeding in corn pays, you know, you want to maximize the potential of planting technology. You want to have the higher seeding rates in your productive areas, and you want to lower the seeding rates where they may not be that much beneficial to you. So make sure you're using that technology to look into some of the practices that you can easily implement with the technology that you have today. With that, I'm going to end there, running up on my 20-minute time cap there. I know I missed a lot of other basic stuff, but again, I kind of want to focus on some of the critical components and also some of the technology. But we do have this simple planter checklist available on UG Extension website that you can just easily access. That covers a lot of like toolbar, drive chains, parallel arms, or any other few of the things I talked about today in here. Again, thank you everyone today for joining in, or if you're listening to my talk right now, and I would be happy to take any questions or comments.